Hi, Spring fans. Welcome to another installment of Spring Tips. In this week's installment, we're going to revisit yet again our Spring Authorization Server. In the first installment, we looked at the happy path for the Spring Authorization Server, how to set up a brand new Spring Authorization Server, how to set up a simple API that we've protected with OAuth, and how to act as an OAuth client, which is to say, to act as a Java process that has an HTTP endpoint, that has a filter that when you attempt to use it and contact it and make requests to it without a valid OAuth token, will then initiate the flow, the OAuth dance, by redirecting you to the authorization server where you will finally do the authentication, and then you'll be redirected back to the OAuth client. We looked at that in the first week, and that was a simple happy path. The three things that you need: the OAuth authorization server built on the amazing Spring Authorization Server, which is amazing because it's useful out of the box with just a trivial amount of code, but it's also amazing because it's Spring. And Spring is meant to be configured, right? You can compose it any which way you want. It's not a monolith. It's not inflexible. It's delivered, in fact, as just a set of auto configurations on the Spring initializer, start.spring.io. Then last week, we looked at how to integrate two different kinds of clients. We looked at a static JavaScript-based page, a trivial single-page app. Okay, not a particularly robust one. The scale of the single page app is immaterial here, right? It would work exactly the same. I spared all of you from having to install npm and having to compile the single page app and all that. It's just a regular index.html with some JavaScript. Not a big deal, but it works exactly the same as any single page app built with React or Vue or Angular or whatever, okay? Now, this week, my friends, I want to turn to the auth server itself. And I want to learn how we can harden it just a bit more, because right now, as trivial as it was, it's not really production worthy, is it? Because as soon as you restart, there's all sorts of computed state that gets destroyed, obliterated, and then recomputed every time you restart. That can invalidate the lifetime and the tokens that have been vended by that authorization server. Things like your client definitions. Right now, in order to affect your clients and your users and all that, you have to recompile the code. That's not going to work. You're going to want self-service sort of administration consoles that you can use to add more users and to sort of operationalize your authorization server, right? Ditto for your keys. You want to be able to do key rotation. Ditto for your authorization and authorization consent infrastructure. So all of this stuff is configurable thanks to Spring Security and Spring Boot auto configuration. And today we're going to take a look at all that in kind, one step at a time. I'm going to be doing it all in terms of Postgres, right? We're going to use Postgres to create durable sessions, clients, tokens, etc. That said, these are all key SPIs. They're interfaces for which there are implementations. It happens that there are implementations supporting JDBC for all of the interfaces, but you could also plug in your own, and there might even be other implementations that are of interest to you provided out of the box based on the use case. So feel free to explore. My friends, let's dive right into it. All right, we've got our authorization server securing not just the regular API, but also a static JavaScript application and a messaging flow, a messaging and integration flow. Very cool. Now, I want to fine-tune the authorization server itself, because as good as all this is, the authorization server is a little bit more than just a demo at this point. What happens if we restart? Well, a lot of computed state gets flushed away, right? It's all ephemeral. We didn't configure any durability. So let's now turn our eye towards the authorization server itself. We're going to change this to work with a Postgres database, which we have running in the background because we have our Docker Compose file that I've started by running Docker Compose up. And we have Postgres here, and we have RabbitMQ. So we want the application to work with and talk to that instance. So let's go to our build.gradle for the auth server. And we're going to add some key dependencies here. By going to start.spring.io, we want support for JDBC, for Postgres, and for the authorization server. And for a Spring session. Let's just copy and paste all these bits. All right, there we go. Spring Boot Starter Test, Postgres, Spring Session JDBC, Spring Boot Starter JDBC. We don't need the second one. Spring Boot Starter Web and Spring Boot Starter OAuth 2 Authorization Server. Command-Shift-I to force IntelliJ to reload the authorization server dependencies. Well, first things first. I want to store the session itself, right? Remember, this is going to keep, whenever we create a request, whenever we authenticate, this is going to establish a session. That session contains information about the current ongoing client use of the token. We need to store that somewhere. Might as well be in the session, but we want that session to be durable so that if we have a load balancer and we put the auth server behind the load balancer and we route from one host to another, from one instance of the same auth server to another, it doesn't matter. As long as the client has the valid cookie, they'll go to the right session state if it's stored in a SQL database, for example. Spring Session is a very convenient API about which I've spoken before. You can use Spring Session to store your session information in MongoDB, in Redis, in SQL databases, in EHCache, or whatever. There's all sorts of different implementations here. It's just transparent to you. Use the Spring Boot starter. It'll auto-configure the Spring Session support, and it'll automatically make it so that when you use something that in turn uses the servlet API to write things to the servlet session, it in turn is talking to your delegate session, and that's going to talk to your persistence provider of choice. So we need to configure, first of all, the auth server to talk to our SQL database. So auth server, we'll go down here, add some new configuration. First things first, Spring data source URL, JDBC, Postgres, QL, localhost, Postgres, username is Postgres, and the password is Postgres. All right. And we want to tell Spring to initialize the SQL database with some SQL files. So we're going to say to run the initialization routine. Now, what are we going to initialize? Well, we're going to create a little file here called schema.sql, and we'll put some tables that it's in the documentation, but we're just going to use one that I've already made sure works with Postgres. All right. So create table if not exists, Spring session. We got the primary ID, the session ID, the creation time, last access time, max inactive interval, the expiry, etc. We've got some indexes, etc. So we've got all this stuff here. And then we have also for the attributes. So this contains the definition of the session, which has a 1 to n relationship with attributes in that session, right? And there's some indexes and all that. Not surprisingly, this is super useful in the world of security. And so it's even less surprising that this project, Spring Session, was initiated by Rob Winch, lead of Spring Security. Very, very useful project. Okay, let's go ahead and restart the auth server. Okay, everything's up and running just as before. Let's go ahead and try our flow. So 127.00.80.82. Okay, let me create a new one here. Okay, 1 PW user read consent. Okay, very good. So we're back to where we started, but did it work? Did we actually end up making our session durable? Let's try it out. Let's log in to our Postgres instance. So PG password equals Postgres, pSQL, u Postgres, h localhost, database schema, Postgres. All right, so we've got now, there's our Spring session table. Okay, so we've restarted the auth server. Let's go ahead and check in Postgres. All right, there's our customer data from earlier when we updated the resource server, the API to have customer data. But also we have the Spring session table. So select all from Spring session. Nothing in there. Now let's log into the service. 1 PW, authenticate, hit yes, hit submit. All right, this seems normal. What about our application? And there we go. There's our single session. And if we look at the attributes, you can see there's data in there, binary data, but data nonetheless for 2 attributes. Very good. So now we've got durable session state. Great. This is a start. What else can we make durable so that it survives restarts, right? We want to be able to hit, if let's say we deploy the auth server 10 different times, we have so much scale. We need 10 different instances of the service running. And by the way, now is a good time to mention that the auth server is built using blocking IO. And if you're on Java 21, this is a great time to enable virtual threads because it's going to benefit you tremendously here, giving you a lot better scale. Okay, so we've got the session. What about the users? Well, right now, we are creating users manually here. We're creating a user details manager, and I've got hard-coded usernames and passwords, providing scopes and literal plain text passwords in memory in Java code. So this is not good. How do I administer the session, short of updating the code, committing it, and then recompiling and redeploying? Right? If I want to add more users, I have to do that. That's not going to work in a real production-worthy sort of authorization server. So let's get rid of that. And instead, we're going to use a JDBC user details manager. Okay, so now here's our new configuration class. It's got our user details manager, and that's enough, right? Usually that's enough. All I'm doing down here is I'm loading up the database. I'm writing some records to the SQL table using a Spring Security User Details Manager, which is an extension of User Details Service that has methods to create, basically to manage users, not just read them as we have in the user details service. So the user details manager provides extra, and this is just for our demo. I'm going to hard code create some users. The password here is PW, and I got these passwords by going to the Spring CLI. So I said Spring encode password, and then I'll just say PW, for example, and it gave me that value. I can run something like pb copy on the Mac, which copies it to my pasteboard, and I can paste it there. Okay, make sure to get rid of the new line at the end. Now, even if I ran the same command again for the same exact password, because I'm using bcrypt, there's no guarantee that the resulting string would be exactly the same as the first one. And in this case, there's not, right? That's okay. It's part of the algorithm. Okay, good. So I have two users. One is Jay Long, that's me. One is Rob Winch, lead of Spring Security, that's him. He would be vehemently opposed to such a very insecure password as PW. So please don't mention it, would you? Just leave poor Rob Winch alone. Okay, so PW is my password, and it's definitely not his, but he's been given no say in this matter. It's don't blame him. So this is the username, and I'm just going through each of the users and the passwords here in this map, and I'm saying, hey, manager, does this user by this username exist? If not, then programmatically build one up and then write it to the database. And again, it's only if it doesn't exist. So this will only run the very first time, and it's just for our demo. Obviously, you could easily imagine building an administration console or something that lets you administer users in your system. This is just a very simple demo here, and I'm giving every user the one authority role called user. But you can imagine user and admin or whatever. Remember that before we had two users, one and another user called two, TWO. So we're going to change that now. This is no longer a valid user. Okay. So this is the auth server. We have our username and password and all that stuff specified there. We have the schema for Spring Session, but what about our users? And what about their authorities? Well, we need to add some schema. Now this comes from the JDBC user details manager. It's actually provided here. You can actually see there's a SQL statements in here and all that. And in the Spring Security jar, deep in the jar somewhere, you'll find the actual SQL files. But I found it. It'll be in the Git repository for this code. And this is working for Postgres, okay? It might be a little different for your SQL database of choice. All right, let's go ahead and rerun the auth server. Fantastic. Okay, so now we need to restart the resource server, or at least the gateway, right? The auth client. Let's restart the client. So run this. Okay, so the client's up. That should invalidate the session. Let's go ahead and Command-Shift-I, new incognito window. And the username is now JLong. And the password is PW, okay? For the client, on behalf of the user, JLong, do I want to allow access to user.read? Yes. And then it says, welcome JLong. So now, if we go to the SQL database and query, it says, oh, okay, here, what users do you have? Select all from users. There you go. Now, this is the exact text. This is the bcrypt encrypted password. So I'm storing this text directly as we saw it in the Java code, but obviously this is not plain text. If it was plain text, it would just be PW. It's computationally almost impossible to turn this password back into the letters P and W, okay? It would take computing power, the likes of which most people don't have, or if anybody has it at all, short of quantum computing getting a lot better very quickly. So now we have our users being stored in the database. That wasn't so bad. Actually, this code, again, this is a demo. So really the sum total of what we had to do to store users in the database instead of in memory was this. And I could have added this one bean up here if I wanted to, but I just wanted to keep it nice and clean and explicit. This is just for our demo so that we have something with which to work, and so that I, your humble host, didn't have to manually craft artisanal handcrafted SQL statements to insert this into the users table directly. You can also see there's an authorities table as well. So select all from authorities, and you can see that for the username called JLong, there's an authority called role user, and for rwinch is a user authority as well. All right, we have durable users. Now, what about the clients themselves, right? So far in the auth server, we've been configuring clients in YAML and in properties, right? You can see we've got this explicit sort of hierarchy of properties, and I could have done this in YAML. I probably should have, but really all of this defines one client called client one, logically called client one, but the name by which it's referred to and everywhere else in the system is client. And it's client ID, client secret, client authentication methods, authorization grant, the redirect URI, etc. All of this is what you get if you went to developer.twitter.com or whatever and created a new app. They would ask you to specify this kind of information. Where do I redirect? What scopes do you have? what's the client ID, what's the secret, what kind of authentication methods do you have, and what kind of grant types and grant flows do you want to support. I'm doing all of this in the property file, which is fine, except again, in order for us to change this, we'd have to redeploy after making changes to the code. So let's now derive those clients not from this property file, but from Java code. All right, here's our client configuration, very much in the same style as we did for the users. I've registered a bean of type registered client repository for JDBC. Okay, if you look at the Java doc for that, you can see if you look at the source code, there's SQL statements aplenty, and then in the definition itself, there's information about which SQL files to run and so on. And of course, by the way, there's also runtime hints. You can see I helped with that. There's my name right there, so that this all works in native as well. So okay, good. So we've got that. Now this is this is going to expect some SQL. So let's go ahead and add that to our schema.sql file. It says OAuth2 registered client, all the different parameters. And again, this is optimized for Postgres in this deployment, but to each their own. And again, same pattern as last time for the client and the users as well. We're going to create an application runner that gets initialized when the program starts up. We're going to inject this newly minted registered client repository. If there are no existing clients by the ID of client, then save a new one. And we're building it up programmatically just so I can avoid having to write it by hand. But again, you wouldn't normally do this. You'd have some sort of administration system or something like that to let users manually self-service, add users, and add clients, right? And they'd probably use the same API behind the scenes, but now you can understand what we're doing. So again, the sum total of what we had to do is we had to define this bean and that schema, and that's really it. Okay, so let's go ahead and restart. And by the way, what is the password for this? Well, it's probably the same password as we use here for the secret, right? It's whatever that is. And we can find out what that is by looking at the API itself, the OAuth client, the gateway. The password is password. The client secret is password. So you can see we're specifying that here. And, hopefully it's the same thing in our new JDBC code. Let's restart the auth server. Okay, great. So now, same as before, let's new incognito session. Go here. Okay, JLong, PW, log in, and we're in again. Now, do we see that reflected in the database tables? So we see OAuth2 registered client, select all from OAuth2 registered client, and there we are. There's all the information related to that registered client in our SQL database of choice. Not bad, huh? Very cool. Clients tell us the nature of the thing accessing our secured resources. That is to say, is it a browser? Is it an iPhone? Is it an Android device? Is it a TV screen or something? Because they have different kinds of authentication types. Maybe they need to do client credentials versus authorization flow versus whatever. I mean, there's all sorts of different nuances there. And OAuth, and its many myriad nuances and permutations, supports all of them, but they can be client specific. So you configure that, and then users authenticate via that client. They authenticate on the authorization server, but the authorization server handles their authentication flow by the way you've configured that client. So you create a client called the browser. Maybe your website has an iPhone app and a browser-based app. Okay, you'd have two different clients, but it's the same user. So either way, Josh logs in as Josh, but if he accesses it from the browser, then he's going to use the browser-based client. If he accesses it from the iPhone, he'll use the iPhone client. Okay, you configure two different clients in the system that way. Now, once a user has authorized certain authorities and certain permissions for the client, well, that's an authorization, right? That's an authorization and an authorization consent. So we want to store that durably as well, that choice, the election, in that case, for that consent screen, when it said allow the API to use user.read or whatever it was, that's an authorization and consent. We want to store that durably. This is easy enough to do. Same kind of thing. We just register some key interfaces here. So here's our implementations of the authorization consent service and the authorization service. All that. And of course, there's some corresponding SQL to add. Okay. All right. So we have the authorization, the OAuth2 authorization and the OAuth2 authorization consent tables. Those are in place now. We're going to go ahead and just restart the auth server just as before. Go back here, close that, create a new incognito tab, JLong, PW. There we go. So now if we go to the SQL database, we can see we've got the OAuth2 authorization and OAuth2 authorization consent tables. We've got nothing there, but what about the authorization? There we go. All right, good stuff. So now we've made almost everything durable in our system that can be made durable easily. Everything, that is, except for one thing. And this is a big thing. This is the keys, the keys that we use to sign the requests. Basically, the foundation of our trust in the JDBC tokens stems from our trust in these keys. And those keys, if they ever become compromised, need to be rotated. But we want to make that choice about when they get rotated. We don't want the authorization server to do that, because remember, if you rotate them, they become, you might invalidate keys that are outstanding, right? And every time you restart the auth server, you end up invalidating it, because those keys are generated in memory ephemerally on every restart, right? So what we want to do is to, first of all, have the ability to, on our whim, press a button or call an API endpoint and have the keys rotated, and then also generate the keys on startup, and then also make those keys durable in a secure way. So this is going to require a fair bit more code. Actually, this is a little bit of extra homework. We're gonna walk through this, but we don't just trust me. You don't need to understand all of this. This is definitely an advanced feature. Okay, I've copied and pasted the code here. We'll walk through it in a second. Let's take care of some other stuff before we walk through it. First, we need to add some things to the schema, right? As always, there's the schema to support persisting our RSA key pairs. We're going to configure a default key. So I've copied app.key and app.pub here. We're also going to need some configuration. So I'll put that in here, telling us where to find the app.pub and app.key and the salt and the password that we're going to use to encrypt those keys when stored in our SQL database. Now, important question. Who secures this key? Right? This is a key. This password and this salt, these are keys in of themselves. And it's turtles all the way down. This is a good question. Arguably, we should be using something like HashiCorp Vault to store these RSA keys, and this wouldn't be required at all. Worst case, this could be an encrypted environment variable with some sort of encrypted and injected seed that you use to then decrypt this, which you can then use to read the values in the SQL database. But for our demo, just to keep things simple, I'm going to keep this all in plain text so we can kind of understand what's happening. But this should not be checked in. These values should be external to the code, okay? Password and the salt. This is how we're going to know how to persist these values. Okay, so we've got our app.pub and app.key. We've got our updated schema. Now let's revisit that Java code, because there is a lot, friends. This is quite the implementation. There's more code here than in the entire rest of the system. But it's a kind of an interesting exercise. And arguably, it's not something that you should have to do. Again, you can use Vault or something like that. But if you want to use it and you want to do it, you have that flexibility. And that's part of the reason I love the authorization server. First things first, it's just, we got a configuration here that listens for the application ready event. So when the Spring Boot application starts up, we get a notification, at which point we inject the event publisher and we inject something called the RSA key pair repository. We created this. This is our repository type. It's just a way that we are going to use to store key pairs. And we're going to look at the repository and say, hey, are there any key pairs? If there are not, then let's publish an event of type RSA key pair generation request event, which again, we created. This is not in Spring Security, with the current time. And that's how we're going to bootstrap things, right? And then the listener for that event is right here. It's another event listener. It's going to listen for this RSA key pair generation request event. And we're going to inject the key ID, which is beautiful, the repository, and the keys object, which is the util class. And we'll use that to generate a key pair with the key ID and the source, which is this right here, the event. And that's it. We're going to generate a key and then store it. Okay. So if we look at generate key pair, this is a little utility class. This is actually the hardest part, is using the Java security interfaces to, first of all, generate a key pair down here, key pair generated.getInstance RSA, initialize it with 2048, and then generate the key pair. That gives us a Java object called key pair. And here we're getting the public key and the private key, and we're wrapping it in this little record called RSA key pair that, again, we created. Okay. So we got a repository that stores these records, which have an ID, the time, the public key, and the private key. And we have a save method and a find all key pairs method, okay? Here's the application event. You can see it's not all that fancy. We have the current time, when the request was made, and that's about it. So far so good, right? We have an event that gets published. You can publish it whenever you want. We publish it once the application starts up, just to make sure that we are never in a situation where we have no keys. And you can publish it again. You can imagine building an admin console or something like that publishes this event to force evict and rotate the keys manually. Okay, so and when that event gets noticed or when it gets handled, we write a new key pair to the repository. We have a text encryptor using the injected password and the salt, right, from the configuration. We have a Nimbus JOT encoder, okay? This in turn is what handles encoding the JDBTs, which in turn uses a JWK source. This is the thing that provides the keys for the tokens. Okay, we'll come back to this in a second, but this is how we plug in our persistence and our mechanism for keys into the pipeline. Spring Security defines one of these. It needs this, and there's a default implementation that's in memory. We're overriding that. We're telling Spring Security to use our Nimbus JOT encoder. Here, we're creating an OAuth2 token generator, passing in the JOT encoder, which is this thing right here, passing in an OAuth2 token customizer, and we're just some very pretty procedural stuff. This is exactly as was in Spring Security. The only difference is that we're telling it to use our JOT encoder, which in turn is using our JDBK source. So let's talk about the JDBK source. Let's go back to here. There we go. So this is our RSA key pair repository JDBK source. So we created this. It implements JDBK source and OAuth2 token customizer. And basically, when the client sends a request that we need to then load the key for, it calls this method, passing in a selector, which is kind of like a query for key pairs. And we then pass it onto the repository, get back a bunch of results, build up the RSA key pair by using the RSA key builder. And we basically just take the values from the SQL database and then put them in these objects. And if they match, then we return them in this collection of JDBKs. Pretty straightforward, right? This is all pretty straightforward. The magic is really this repository, okay? And then same thing here. If somebody wants us to customize, we look at the repository, get the thing, and set up the JDBS header. Okay, so we've seen the core moving pieces. JDBK key source, in turn, talks to our repository. What does our repository look like? We've seen the interface. We've seen the event. Here's the actual this is the reason. From here on down, this is just SQL and persistence and reading and writing key pairs. It's boring code, but it is the meat of the code. So if you're interested, but if not, you feel free to skip ahead. We're basically done. So JDBC, RSA key pair repository, implements RSA key pair repository, just injecting a key pair row mapper to talk to the SQL database. This is a SQL JDBC client or JDBC template row mapper. We've got a public key converter and a private key converter. That's these types right here. They're implementing serializer from Spring Framework, right? So we can serialize and deserialize RSA private keys and public keys, right? So here's the private key converter. Basically, given a input stream, which is the private key, we are able to decrypt it. We're going to get the input stream, turn it into a reader, then decrypt the reader, and then given that value, which is a string at this point, we're going to replace the dash begin private key with quote quote dash end private key quote quote. So now we have the content. It's like a sandwich. We've got the encoded values. We decode the base64 encoded value of the key, and then we use that to create an actual key in Java object, from Java security interfaces, and that creates a private key. So basically, this is how we get an object that we can then use in Spring Security from a string that has the contents of the key. And then if we want to serialize it, same thing. We get the RSA private key, and we want to write it out to an output stream. So this is given an input stream, give us a private key. Given a private key in an output stream, here's how we encode it. We take the value, we add the begin private key, we encode it, and then we add the end private key, and then we just write it out, right? Output stream.write, get bytes. Same thing over here for the public key. Although for the public key, we don't really need to do all this encryption and decryption. It's public, right? That's the whole point. It's wide open. We do it anyway, just because we can, but you don't need to. So get the key instance, decode, generate the public key, blah, blah, blah. Same kind of procedural code, okay? We have a row mapper. This is the actual thing that talks to the SQL database, right? It's given a result set for each row, get the private key bytes out of a SQL table called private key, deserialize from byte array using the converter, get the string for the public key, get the bytes, deserialize from byte array, give them the public bytes, get a date, right, from the date column, and then we create a RSA key pair. And this is what you get back from the repository, right, is the RSA key pair with the ID that created the public and the private key. Finally, here's our repository, the implementation. Again, low-level stuff, right? We're just, selecting all from RSA key pairs, ordering by created, getting results, turning them into RSA key pairs by passing them to the row mapper. And then given an RSA key pair, we insert it into the database, using regular stock standard JDBC template or JDBC client infrastructure. We register the converters as Java configuration, and we're ready to go. So let's go ahead and restart this. Okay, there's our auth server. Let's go ahead and rerun our same request. 127.80.82 JLong PW. Okay, the request seems to have worked. Let's go to our database here, and we can see our table, select all from, and there we go. There's the encrypted, encoded value of our key, and that'll survive. That'll be returned. It won't be created again because it's already there, and it'll be returned next time. So even if we restart the auth server, it should still get the right value. Pretty cool, huh? Now we have a hardened, scalable, integrated authorization server at the heart of our system. It can handle any kind of client, any kind of integration use case, and it's now durable. I could take this to production and feel very happy that I have things doing what I want them to do. I have the ability to configure it and to operationalize it and to administer it. We started with something small and trivial, and we scaled up, adding as we needed and adding only what we needed and no more. I love this. This is the power of Spring. My friends, we've got good security while also having it our way. It's a wonderful thing. I hope you got something out of this series here, looking at the Spring Authorization Server. I'm a huge fan, and I'll be talking about it more, but that does conclude our series for now. Okay, we'll certainly talk about the Spring Authorization Server again sooner rather than later, but we're done for now. Okay, next week we'll move on to something else. Thanks for joining me as always, and we'll see you next time.